Moving on with examples of graphing rational inequalities. So the first example that we saw was a pretty easy one. Let's go ahead and move on to our second example. Not that much more complicated, but there is a little bit more to it. And so I suggest that you pause the video and see if you can get the answer to this one on your own. All right. Now, I know technically I need to set this equal to 0 first, but before I do that, I can actually move my domain step up. So you might even want to move domain to step number 1 rather than step number 2. Domain in this part, since we're only focusing on fractions, is where our denominators are equal to 0. So if I look at my first denominator, I know that I'm going to have a vertical asymptote when x is equal to -4. If I look at my second denominator, I also know that I have a vertical asymptote at x is equal to +5. So I need to recall these because these need to go on my number line because my graph can switch between above and below my x-axis there. All right, moving on from that, now I just need to set this opposite of 0. So I'm going to move one of my fractions to the opposite side. So I'm just going to subtract that second fraction here. Now I can multiply by my least common denominator to cancel out my fractions, and I will do that eventually, but it actually might be a little bit easier to put this in one fraction format. So when we are doing that sign chart, we can plug it into a simplified piece. So I'm going to multiply this fraction over here by x minus 5. And I'm going to multiply this fraction over here by x plus 4. And we need to multiply those in both the numerators and the denominators. So on the left, when I FOIL this, it gives me x squared. On the outside, -5x. Inside -3x gives me -8x. And last is +15. And that's over my LCD, x plus 4, x minus 5. Minus this fraction, if I FOIL this, gives me x squared plus 6x plus 8 over, again, my LCD, x plus 4, x minus 5. This is still greater than 0. If I want to combine these two fractions, I need to distribute this negative here. So I make it a positive and I distribute my negative all the way through. Okay, so my x squared minus x squared cancels out. I have -8x minus 6x gives me a -14x. And then 15 minus 8 gives me 7. And that is over my LCD. And this is still technically greater than 0, but I can set it equal to this 0 at this point because I know my answer is always going to be the greater than. Okay, I can simplify the numerator a little bit more by factoring out a common factor. So I'm going to factor out a -7, and that leaves me with a positive 2x minus 1. And I'm doing that, again, to simplify this for my sign chart. And that is over my LCD, x plus 4, x minus 5. All right, now if I want to actually solve this, I know I can multiply by my x plus 4, x minus 5 on both sides of the equation, and that would cancel out that there. So on the left, I'd be left with -7 times 2x minus 1, and on the right, I have 0. So when I set each of these equal to 0, this one gives me no solution whatsoever, and then this one here gives me x is equal to 1/2. So that's going to be my intercept or my boundary. So I need to put my boundary and my vertical asymptotes on my number line. -4, 1/2, and then 5. So I need to figure out what x values I want to use in each of these intervals. On the left, I'll use -5. Here, I'll use 0. In between 1/2 and 5, let me just use 3. And beyond 5, I'm going to use 6. And I'm going to plug it into this equation here. So that is negative 7 times 2x minus 1 over x plus 4, x minus 5. All right, so negative 7, if I plug negative 5 in this here, it gives me negative 10 minus 1, which is negative. Negative 5 plus 4 is negative, and negative 5 minus 5 is negative. So all of these are negatives. An even amount of negatives tells me that they all cancel out, and this is positive over here, or above my x-axis or greater than 0. If I plug in 0, I have a negative 7, 0 minus 1 is negative, 0 plus 4 is positive, and 0 minus 5 is negative. So I have an odd amount of negatives, so this is negative or below my x-axis. If I plug in 3, I have negative 7, a positive here, 6 minus 1, positive here, and then 3 minus 5 is negative there. So that gives me even amount of negatives or positive. If I plug in 6, I have negative 7, a positive here, a positive there, and a positive there. So it gives me negative or below. Okay, so we're pretty much finished. All we need to do now is select our appropriate answer. This one is greater than 0, so I'm looking for where I have my positives. So my two answers are these two intervals here. So my first interval is from negative infinity up to negative 4. This is just greater than 0, so I do not include it. And then my second interval was 1/2 to 5. Now it didn't matter in this one because I only had the greater than, I didn't have the or equal to. But I always do suggest that you draw vertical asymptotes where your vertical asymptotes are, so you don't ever accidentally select them as an answer. And again, if you want to designate this one as an intercept, then that would be great to put that point there. Okay, let's go ahead and graph this to see if we have the correct answer. All right, so I have graphed this on my Desmos. I have my equation of my two fractions here. I always try and put the most unsimplified problem in there because if I made any mistakes in simplifying it, this should hopefully catch those mistakes. So all I have is when I have set this opposite of 0. So I have x minus 3 over x plus 4 plus x plus 2 over x minus 5. I knew I had vertical asymptotes at negative 4 and 5, so I went ahead and graphed those to help us understand what's going on. This problem was looking for it is above the x-axis. So I see that it is above the x-axis here, and then it is also above the x-axis here. So if I even wanted to go a little bit farther and highlight that, I see that it is above the x-axis all the way here. So that interval would be on the left, negative infinity, up until my vertical asymptote there, which is negative 4. And then I also see it is above my x-axis from here. And so that starts at my intercept, which was 1/2, all the way up to this vertical asymptote, which is 5. And so this would be my answer, and of course that is the answer that I had here. Negative infinity to negative 4, and then 1/2 till 5. All right, so we've finished up this example. I have another example of special cases just like I did with the polynomial function. So that's what you'll see in the next video.